Hello everyone, welcome to my YouTube channel Civil Spare Insights. In this video, I will discuss some important MCQ for soil mechanics. Already I have discussed the expected question for various subjects. So if you have not watched them, you can watch by clicking the link given in the description box. One request, if you have not subscribed my channel, please support me by subscribing and sharing. It's a newly created channel, so please subscribe. So let us begin with the first question. The collapsible soil is associated with. So here collapsible soil means the soil that collapse under the small loading, or it cannot bear stress, or it that doesn't bear stress. So the answer is loess. Okay. So loess is collapsible soil. It is a wind deposited silt. Okay, remember this point is important. Deposited silt. Okay, loess is wine deposited silt. This is very collapsible. These loess have some strength and steepness in the normal water condition, but in wetting condition it doesn't have any strength, and it doesn't bear the stresses. Okay. So here Blackcotton soil. Blackcotton soil is a expensive soil due to the presence of clay mineral, montmorillonite. Okay, it shows large volume changes. So coming to the next question, loam is a mixture of. So loam is a mixture of sand, silt, and clay. One thing here, these three components should not be more than 50% is in weightage. If it isn't, if any of these three is more than 50%, then we don't call it as loam. Okay, so for loam, sand, silt, and clay must have proportion less than 50%. Okay, so any of them should not exceed 50%. So coming to the next question, relative density of soil is determined for. So relative density is also called density index, right? Density index is equal to the E maximum minus E natural upon E maximum minus E minimum, right? Here E maximum is the void ratio in loosest condition. E natural means void ratio in existing condition, and here E minimum is void ratio in densest condition. Okay, so here relative density is represented for the determination of cohesionless soil. Why cohesionless soil? Because in cohesive soil there are huge number of voids, right? So it is not possible, or it is not easier to find the E maximum. Okay, so the maximum void ratio cannot be find properly for cohesive soil, because there are huge uncertainty in computation E maximum. Okay, so that's why we go for cohesionless soil, right? So coming to the next question, a soil sample has a shrinkage limit of 10% and specific gravity of soil solids as 2.7. The porosity of the soil at shrinkage limit is, so here there is a formula C1, right? So here we know that at shrinkage limit the degree of saturation is 1. So void ratio here shrinkage limit is given 10%, so the water content will be 0.1, right? And G is given 2.7. So here E equal to 0.27, right? But we need to find porosity. Okay, so porosity is equal E upon 1 plus E, right? So 0.27 1 plus 0.27. Okay, so the answer will be 0.212, right? So if I convert it into percentage, then it will be 21.2. Okay, so the answer is 21.2%. So coming to the next question, if the water content of a fully saturated soil mass is 10%, 100%, then the void ratio of the sample is, so water content is here water content is 100%, that is 1, and void ratio is needed to find. Here W is equal to 100%, that is 1. So here E is equal 0, right? That means void ratio is equal to the specific gravity. Okay. Coming to the next question, from among the range of numerical values of given, select the range value for the void ratio E. So if I draw diagram, here soil solid, okay, here water, here air, right? So here air. So we know that void ratio of E is equal volume of void by volume of solid, right? So we know that for void ratio it cannot be 0. Why? Because if it is 0, then it will not be termed as soil. For soil, it must be have some voids, right? They must be have some voids. So to become soil, it should have void, right? So void ratio is not equal to, is never equal to 0, right? So here volume of void can be more than volume of solid. Obviously volume of void can be greater than volume of solid, right? So void ratio may be can be greater than 1 also. So here, so the answer is, so here you can see here E equals 0, so it is cancelled out. Here also it is E equals 0. So the answer is E is greater than 0, right? E is greater than 0. E is always greater than 0. There is no upper limit for E. Okay, it can be greater than also 1 also. So the answer is D. Okay. Coming to the next question, if the coefficient of uniformity of soil is 25 and the coefficient of curvature is unity, then the ratio of D30 upon D10. So here coefficient of uniformity means the diameter of the sphere, or effective diameter of the sphere, or it also called as effective size of the grain, right? So Cu equal, we know that D60 upon D10, right? Okay, here Cc is equal coefficient of curvature equal D30 square upon D60 into D10, right? So here if I divide this Cu by Cc, then what we'll have? We'll have D30 upon D10 square, right? Okay, D60 is cancelled by D60 here, D30 square upon D10 square, right? So now we need to find D30 by D10, right? So here Cu upon Cc equal D30 square, okay, D30 square upon D10 square, right? Here if I take a root over square root, then we'll have, here Cu value is 25, right? 25 upon 1, so here 5, right? D30 upon D10 equal 5, right? So the answer is 5. Okay. So coming to the next question, if the plasticity index of a soil is 0, then the soil is, we know that the plasticity index, there is no plasticity for sand and gravel. Okay, so the answer is sand. So plasticity index is defined by IB, right? So coming to the next question, if the soil is dried beyond its shrinkage limit, this sample will show. So if I draw, this is our Atterberg limit, right? This is our shrinkage limit, this is our plastic limit, this is our liquid limit, and here volume changes, right? And here our water content, right? So here if I this is our shrinkage limit, right? This is our shrinkage limit, right? So here this is the minimum water content at which the soil is saturated, right? So if I further deduct water, if I further reduce water from this shrinkage limit, then it will be in this stage, right? So in this stage volume is not changing, right? Okay, so the volume, no volume change. So a pycnometer is used to determine, water content and specific gravity. Okay, one thing to be remembered here, so pycnometer is used only for cohesionless soil. Okay, cohesionless soil. Why for cohesionless soil? Because in cohesive soil there are large number of voids, okay, and there is no any interconnectedness between them, right? So while doing pygnometer test, we have to remove the entrapped air, right? So removal of entrapped air is not easier, not possible in case of cohesive soil, because the air get entrapped in the voids, because the voids are a large number of voids there are, so that's a problem. So we use cohesionless soil. Okay, we the suitable soil for pygnometer test is cohesionless soil, remember. Okay, so coming to the next question, which one of the clay minerals has expensive properties? As I've already told, this is montmorillonite, right? So montmorillonite is shows expensive properties. It shows volume changes, okay, large volume changes and shrinkage. Okay, and if I talk about montmorillonite, it is composed of two part of silica and one part of alumina. Okay, it is composed by two part of silica and one part of alumina sheet, right? Okay. Example, what are the soil that have, what are the soil that contains montmorillonite? Black cotton soil, bentonite soil. These are the soils that present huge amount of huge amount of montmorillonite. Okay, so coming to the next question, as per the Indian soil classification system, inorganic seals of high compressibility defined with the symbol MH, CH, OH. Here MH means M means silt. Okay, high means compressibility. High compressibility silt. CH means high compressibility clay. Okay. Okay. OH means O means here O means organic high compressibility organic soil, right? Organic clay. So the answer is, as per the Indian classification system, inorganic seals. Inorganic means silt means MH. Okay. High compressibility, that is H. So coming to the next question, falling head permeability test is used for. So we know that falling head permeability test is used for low permeable soil. Okay, low permeable means that can allow low discharge. That is our clay soil, right? Clay, silt. These are the soil in which falling head permeability test is feasible. And constant head permeability test, if I talk about constant head permeability test, then the soil that can allow large discharge, that is our sand. Okay, coarse sand. Okay, it is used for coarse sand, and falling head permeability test is used for fine sand. Okay, the coefficient of permeability doesn't depend upon. Coefficient of permeability is defined by, this is gamma of W upon mu E cube upon 1 E 1 upon S squared 1 upon C, right? Here gamma W means the specific weight of water. So K is proportional to, directly proportional to specific weight of water, directly proportional to void ratio. If the void ratio is more, permeability will be more, right? It is inversely proportional to viscosity. If the viscosity is more, then the permeability will be less. Okay, and it is also inversely proportional to specific surface area of the soil, right? So it is also inversely proportional to the shape of the soil particle, right? So the answer is shape of the particle, no. Void ratio of the soil, no. Duration of flow, right? Okay, so here the answer is duration of flow. It doesn't depend on duration of flow. The dimension of coefficient of permeability, so let us understand what is coefficient of permeability. We know that Q equal KIA, right? Here K is equal Q upon IA, right? Here Q is the discharge, I is for hydraulic gradient, so there is no unit for hydraulic gradient, right? So here we have Q upon A. Q means meter cube upon second upon area means meter square, so we have meter per second, right? So the dimension of meter per second, LT inverse 1. Okay, this is for today. Thank you.